Hello, good morning or good afternoon. So Bell Integrator, we've been around for a little over 15 years. We're based in San Jose, California. At least for myself, I've been with Bell for a little over 6 years, and prior to that, I've spent an extensive amount of time at Deutsche Telekom. But we are a global company. We have a little over 2,500 employees. As I mentioned, I think I might have mentioned we are based in San Jose. We've had an opportunity to work with a number of different companies globally in several different capacities, not just machine learning or AI, but also in a number of other spaces as well. Historically, we've been a systems integrator, and roughly around 5 to 6 years ago, we started building out our own digital portfolio, a number of different SaaS-based solutions. Some of those SaaS-based solutions, as an example, was augmented reality. We built out an IoT solution, some network automation services, and also where we are here to talk about today is Neuton, which is more recently one of our next SaaS-based solutions that we've brought to the market. We've been doing AI for some time, probably like yourselves. We were initially using TensorFlow, using other frameworks that are out there, different algorithms that were out there in order to build out some of the solutions that we were working with on some of our customers. And we found that, number one, it was very time consuming, not only from a perspective as it relates to, let's say, the time that it actually takes to build out a model, but also the time to market, so as it relates to bringing a solution to the market for our customers. And also, even though we do have an abundance of resources, there's just, of course, only so many Daniils around. And the time that it just fundamentally took, and when it came to scalability, we wanted to look to do something different. And really kind of our approach is really to bring AI available to everyone. And we feel that we do this in a couple of different ways. Number one, there's a significant amount of automation in our platform, but really we've streamlined our workflow to be really into three very distinct steps where you basically upload your data, you identify your target variable, you begin training, and then from there you head into predictions. And we've really put a focus on really, for all intents and purposes, eliminating the need for any coding. So it's a zero code solution that we've put together. And even despite, let's say, this being an AutoML solution, we found that our solutions are extremely competitive, whether you're relating to some existing neural network programs or platforms that are out there, or even some non-neural network algorithms that are out there as well. So we're extremely proud in regards to what we are able to produce. And we found that, our customers are getting value out of our platform, whether they're new to the machine learning space, or even if they may have a robust a robust IT department where they have some existing data scientists and they're looking to maybe offload some of those more time-consuming tasks. So in our platform, you'll find a couple of different things. Number one, we have a fairly robust explainability office, which consists of a number of different tools, all of which Daniil will go into detail. So you'll find that we have an EDA, our exploratory data analysis section in our explainability office. We have a feature importance matrix component of our explainability office where you're able to see what are the top 10 features that are influencing your predictions, as well as the bottom 10. And then we have what we call our model interpreter, our what if tool, which allows for you to dynamically change the values of your features and see how they may influence your predictions. And this is one of our latest additions to our explainability office. And it's one of our most popular tools that our customers are really raving about, and just getting a significant amount of value out of taking advantage of that tool. So if you are looking to, let's say, improve your time to market, if you're looking to have more insight into your data, trends, bias, general model quality, so that's another one of the things that we'll do. We'll also inform you proactively when your model may be beginning to decay, and you may need to go through and actually train your model again, and that's also something that we'll highlight with you guys today. We generally like to call ourselves, vertical agnostic. We're working in a number of different spaces with different customers in the financial services. We just recently completed or held a financial services summit where we brought to the table some customers and partners that we're working with, and they were able to kind of share their experiences as to how they're taking advantage of our platform. So the financial services space is an area that we're seeing a lot of traction in. The same thing, let's say, from a digital marketing perspective, also in the retail space is an area that our customers is getting a lot of value out of our platform. And not just there, of course. So one of the things that we do, as I mentioned, is our objective is to bring AI to everyone. So as we kind of begin the process of transitioning over to Daniil, I like to highlight a couple of other different things that we do with some of our partners and customers that we work with. So once someone begins to use our platform, one of the subscription plans that we have is a free plan. But one of the things that we do, because being able to produce a model, as you will see, is fairly straightforward, it's fairly easy, but taking that next step and actually implementing that model and then enabling your customers or your organization to begin to receive that value is what's most important. So we align a data scientist with all of our customers so that we kind of take you through that first step of not only maybe proving out your business concept or just completing your first project successfully, not just on the platform, because that's relatively easy, but also within your ecosystem as well. So with that said, I'll begin to hand it over to Daniil. And Daniil, you can share your screen and begin to walk everyone through the platform.
Hi, Blair. Thank you for the intro. Can you hear me? Can you see me?
Yes, I can.
Hello, everybody. My name is Daniel. I'm a data scientist here at Bell, and I'll be happy to do this demo for you today. Okay, I'm sharing my screen now. All right. So what you see right here is our main working area at the platform. This is what you see after you have logged in. So here you can see each card here represent a machine learning solution, a project where everything happens inside of this card. And we call these projects solutions. So in order to, and here you can see some basic information when it was created, started, and the metric, the target metric value. And it will change dynamically during training if you will be here in this area while the training is going on. So to start a new machine learning project or a solution, you just click this button right here and start a new solution. And today we're going to give you a demo on a house prices dataset. It's a competition from Kaggle. I believe it's called Advanced Regression Techniques. And for those of you who are not familiar with the dataset and the problem, let me quickly show it to you. So there are roughly 1,500 rows in here, and I think 81 or 82 columns. So each row represents one of the houses which was sold, and the price was recorded in this statistics. And every column represents some kind of feature or characteristics of this house. So what is the area, what kind of street it is, when it was built, and so on and so forth. And the last column here is sale price. This is the target variable, which we're going to learn to predict. And the test set has the same set of features, but it excludes the target variable, as you can see. So what's wrong with this data set? Well, first of all, it is not all numeric, and you cannot fit any machine learning algorithm on top of this data set. So this has to be transformed somehow, but we really don't have to worry about it. And we'll just grab it as it is and upload it to the platform. And while the training will proceed, I'll show you what happens to the data set and how it gets transformed. So let's give this solution a name. Let's say house prices. We can give it some description and click next. Here you can see our 3 basic steps. So the data set upload and the target variable definition. Here we define the training parameters and perform the training. And here we use the trained model to make the prediction, to deploy this model, to download the scripts. I will go through all of them in just a few minutes. So let's upload a data set. And you can just drag and drop like this. And the last thing we have to do here at this stage is to tell the platform which is that variable we would like to learn to predict, the target variable. So these are your columns, and the target variable for this data set is sale price. Okay, and before we proceed, let me quickly show you the advanced mode. There are two options in here. You can upload a validation data set if you have one, just like this. Well, we don't have one, and in this case, the platform will perform cross-validation. And you can drop some data which you don't want to be present in the further pipeline. For example, something that you consider irrelevant, like an ID column. But you really don't have to think about that, because the platform will understand which data is irrelevant. It will get rid of that, or will amplify the data which have some meaning to the model. So let's not use any advanced options, and let's just press continue. Here at the training tab, well, you can basically start training right away. But the first thing you want to do is make sure that the training aligns with, or the metric aligns with your expectations. So for this competition on Kaggle, the target metric is root mean squared logarithmic error. And these are the metrics that we support for regression. And for the classification, for example, these are the metrics that we support. And also for a binary classification, in addition to this, there is also area under the curve, Gini, and lift. Okay, let's go back to the regression, select our target metric. And again, there is an advanced mode in here as well. Let's quickly have a look. So 5 major settings. First thing, you can limit the training duration. This is in minutes. By default, it is set at 2 days, but of course, it's not going to train for 2 days. Once the model will start to overfit, the platform will stop training automatically and will deploy the best model up to date. So let's not limit this. You can make the model even smaller. Our models are very small by default, but you can limit the number of coefficients here. Well, this basically translates to weights and biases, which also translates to the size of the model. And you can make the models even smaller. Okay, let's not do that. Perform data preprocessing is enabled by default, and we strongly encourage users to have this option enabled at all times, because not only the data has to be all numeric, but there are various of other techniques we use during data preprocessing stage. And let's also enable feature engineering. I will go through these in detail in a few moments. If you have a time series type of problem, that is, if you have a date time column in your data set and if they are all consecutive and they change at equal step, you may want to enable time series and tell the platform which is that date time column, for example, this one. And to make the training and the prediction even more precise, you can indicate to the platform for which period of time you would like to make the predictions for. For example, if you want to predict 1 month ahead after your statistics, you select the month unit and 1 month. And since it is not advised to break your time series, to break your statistics and your prediction period, if you have some gap, for example, you have finished downloading, collecting your statistics yesterday, and you have 1 week to process it, to download it, to upload it to the platform. So there is a gap. You have broken your time series. You can specify this gap. For example, you have 1 week gap. That way, this information will be used during the validation of the model we are going to train. So this is not a time series type of problem. Let's turn this off. And even without being a time series type of problem, we work with all formats, all known formats of dates. And if we find a date time column in your data set, it will be parsed into up to 13 additional features. We also support text preprocessing. There are now options for that because that is totally automated. So if you have a text column in your data set, it will be processed as a bag of words and lots of new features will be extracted. Okay, so let me remind you that the only thing we have enabled here in the advanced mode is perform feature engineering, and let's start training. So we will stay on the Save tab. Here we'll see the progress line. Our metric value will appear here once the model will start to build and return the metrics. And this new option we have here is, which I have disabled just now, is you don't have to stare at the screen if it takes hours. We'll just text you once it's over, and you can come back and have a look at the results. So here we can see our settings that we have just enabled. Down here under the metrics tab, we are going to show you dynamically all the metrics relevant to this type of problem. So our target metric is root mean square logarithmic error, but for user convenience, we also will show you all the other relevant metrics here, and they will change dynamically. And this one here is model quality index, is what we call it. So here you have by looking at this one picture, you have a overwhelming understanding of how good your model is doing across all the relevant metrics. This will look very interesting once the model will start to send us its first metrics. So when this is going to happen? Well, let's have a look at the log here. So right now, the virtual machine is being created. It takes about 2.5 minutes. After that, the training will start. And the first stage will be data pre-processing, then feature engineering, and then the training itself. We have selected a small data set, so all of this will take about 7 to 15 minutes. So while we're waiting, I have a pre-trained solution here with the same data set, with all the same settings. Let me show you the results. So the training took 9.5 minutes, and we'll be looking over to this step every now and then, and we'll see that it's going to take about 10 minutes as well. So this is the picture in the metrics tab. So this is our target metric, root mean squared logarithmic error. These are all the other metrics, and they were changing in real time once during the model training process. And this is the picture of our model quality index across all the metrics, with this one being the target metric. And this shows us that the model is doing pretty good. Well, actually, it's doing very good across all the relevant metrics. And this is what the log was showing us. So this is just some business information. So you can see that the virtual machine was created, data pre-processing and feature engineering finished, and the neural network was constructed. So while you are waiting for the model to be built, we have an option here to have a look at the exploratory data analysis. So here at the analytics tools, we have the EDA tab. Let's have a look. So this information becomes available during the data pre-processing stage, and we do the analytics, the EDA, before any machine learning. We use machine learning for EDA, but this is performed on your raw data, which you have just uploaded. So let's have a look. There are quite a few sections available for the EDA. Not all of them get filled up automatically. Well, just because, for example, this data set excludes the date time column, so there is no time dependencies plot. But let's see what's available here. The first one is Data Overview, available for all data sets from the start. Here you can see some statistics on your target variable. So this is a regression type of problem. And this is the information on your target variable: maximum price, minimum price, mean, and median. The data set dimensions, here are the missing values, and the data types. Next section, continuous data. So in this case, and one more important note, this data set includes somewhere around 80 features. And some data sets have, well, we have tested up to 4,500 features. And it would be useless to plot 4,500 plots for you, because you'll just get lost in the irrelevant data. So for this reason, we select, by machine learning, we select 20 most important features, and we show you the interrelations between those features. So just the important stuff. So out of those 20 selected features, 8 appear to be continuous numeric variables. And for these continuous variables, we show you the distribution in relation to the target variable. So this particular feature is a greater living area. And here on the left, we can see the feature distribution. And you can see that the vast majority of examples in your data set have a greater living area somewhere around 1,500 square feet. And this is how your data is distributed across your data set, not the data, but the areas, with a small number of examples of some very large houses. And on the right, you have that same greater living area, but with relation to the sale price, to the target variable. And you can see that with increase in the area, the price increases. So the relationship here is, well, linear. And this is a good example of some outliers. You see these very large houses at a relatively small price. So these are the outliers, and they have to be treated. and we work with outliers during data pre-processing as well. And you have that same plot for every other continuous variable in your data set. Next section, discrete data, so the categoricals. And there are also seven categorical variables in here. So let's look at some other plot. This one is not very interesting. Okay, well, this one, for instance. So this is fireplace quality. Again, distribution in relation to the target variable. So this is the distribution. This fireplace quality feature has 5 different categories, and this is how they are distributed with the majority classes of GD and TA, and this is the number of examples in the data set, and these are the minority categories. And on the right here, well, a similar picture, but you can see that the categories here are mixed up, with X, one of the least represented categories, being having a highest bar. Well, this is because here the height of each bar represents the mean target variable, mean sale price. So this feature here, this category inside of this feature has the highest sale price. I presume this is something like excellent, good, fair, poor, something like that, because it just makes sense. I really don't know what exactly they mean. And you can have a look at all the other categorical variables in here. Okay, the next section here represents the target variable, and this is a regression type of problem. So for the target variable, we'll show you a violin plot where you can see again the distribution of the variable with median and the outliers here, the extreme values of the target variable which fall out of the normal distribution. And for the classification type of problem, this, along with all these plots, would be all different. So here we can see that our prices range somewhere from around 100,000 to 250. This is the normal distribution of this feature, and a small number of outliers. And this is also very important because with median of $163,000 for a house, some 2 examples of $750,000 price can really mess up all of your statistics. So we deal with these as well during data pre-processing. Okay, so the next section here is the correlation heat map. Now for this section, out of the 20 selected features, we select 10 with the highest binary correlation with the target variable. So this is our target, sale price, and these are the 10 features with their highest binary correlation with the target variable. And this is a 10 by 10 matrix, and you can see the cross correlations between your features. Well, let's find some big one. Like the garage area is very highly correlated with garage cars, which again totally makes sense. But you can find some really unexpected correlations in your variables, and we've seen some examples during our analysis. And there is one more plot to this. These are the columns with very high mutual correlation. So the mutual correlation between the columns is over 70%. So the pool quality with pool area, garage cars and garage area, and so on and so forth. This is also important because some of these features may be considered noise because they will just repeat the other feature, maybe in other scales and in other numbers, but they will completely repeat the other feature, and one of them should be considered as noise, and it should be either removed from the data set or treated. And we also look into this during our data pre-processing pipeline. The next section is my personal favorite. So this is the missing values map. And there are 2 ways we show you the missing values data. So this first one might look not very informative at the start, but because there are no names, no percentages of missing values, but these are your features. And from this plot, you can see sort of you can have like a bird eye view on just how much data have you got or have you got missing. And we can see that you have missing values across quite a few columns, but all over the data set, it's rather filled with good data. And if you want to look at the details, you can hover over to the right, and we can show you up to 20 at a time. And here you can see feature names and the actual percentages of missing values and the locations of your of your missing values in your columns. So these are your indexes. This is the first row, and this is the last row in your data set. And these are the exact locations of missing values. And why this is important? Well, first of all, you can see here there is some kind of a pattern across these 5 columns where missing values appear at the same identical locations. And this may be an indication of either the interdependencies between the data, and if some data is missing in one column, it will automatically make all the other data missing because it is a derivative of one of the columns, or there is some error or mistake in your data download, upload, transfer, archiving, and you might want to go back to your ETL pipeline and see what's going on there. And just to give you another example, I have another solution here. It is also a regression type of problem, and again for the real estate prices, but there is a very interesting missing values map here. This data set is quite larger. It's about 30,000 rows. But if you want to look at the details here, this is a good example of a lost flash drive. And you might want to go back and see what happened here, why this data is missing, and then do something about it for your next data collection process. And this one is also some kind of a pattern where something is missing here, something was deleted or not transformed correctly. So you might want to go back and investigate. And by the way, this data set includes a date-time column. And in this case, we show you a time dependencies plot. And we always make 3 plots. So the first one is no aggregation whatsoever. These are your dates. And this is the target variable. In this case, real estate prices. And well, this is not very informative, right? Well, just because there are 30,000 points here connected by one line. And if there would be a million rows, then this would be a straight line. And for this reason, we make 2 different aggregations. So this one is here, monthly aggregation. And here you can see a clear upward trend. And this is a weekly aggregation. And if your data set would have maybe 2 days of statistics collected every second, in this case, we'll probably make an hourly and minutely aggregation. It all happens automatically depending on the time frame in your data set. Okay, let's go back to our EDA on our example. And the next section here is the outliers. And we show you 2 plots at a time, and we calculate outliers on the for only the continuous variables, well, obviously. And greater living area, you can see all the areas in your data set, and these are considered to be outliers. And just for user convenience, we show you again here the relationship with the target variable, but the target is not used during outliers calculation. This all happens within each numeric column independently, but this is just for a user to be able to see what are the corresponding prices or the target variable values for each feature. Okay, that's it for EDA. And let's see how our model is doing. And it also has finished training. So we can see here in the training, well, we have the exact same metric here. So it's the same data set, the same example, and it took one second longer. Okay, let's go to the predictions tab. Here we can use our trained model. And well, first things first, here we have this one very important indicator, historical model to data relevance indicator. Now what it is, well, let me give you an example. Suppose you've trained your model and you're happy with the metric and you've used this model in production and it fits you well. It does very good predictions and you depend on the predictions of this model. And suppose you've trained it 1.5 months ago or maybe a year ago, and at some point in time in your business, you start losing money. And once you understand that your model is performing poorly, by this time, it may be too late. Now, why this is performing poorly? Because the data has changed. The new data you are sending for predictions is now different. It has different dependencies, different relationships, different distributions, just because the world is changing. So every time you will upload your new data for predictions, we'll calculate the differences between the data you are uploading for predictions and the data used for training. And here we'll show you And once you will upload your first data set for predictions, this is how this is going to change. Give it a second. Okay. Historical model to data relevance indicator here is 99%. So the data uploaded for predictions is very relevant to the data that was used for training. And this sakura tree is all nice and pink. And once this indicator will start to decay, well, this is going to change colors and it will lose leaves, and you will know when it's time to retrain your model. So this is the indicator of retraining your model on fresh statistics. What else? Very important thing here, available only after the training is over, a feature importance matrix. Let's have a look. So these are your features, the top 10 features ranked by their importance to the model. And these are, well, these are the top 10. You can have a look at the bottom 10 and you can see no importance whatsoever. And actually you can export the whole thing and have a look, and only the top 15 or 17 features will be somewhat relevant to the model. All the other data will be useless. And so what can you do with this information? Well, first of all, you can, if you are happy, again, if you're happy with your model and you understand that only maybe 25% of the features are necessary for this model, you can go back to your data collection pipeline and maybe save some time and resources for not collecting that data, not storing it, not processing it, and only using the data relevant for your problem you are solving. Since we have performed feature engineering, we can also have a look at the feature importance matrix with the engineered features. And let's have a look. And we can see here at the top 10, we have quite a few features that were engineered by the platform. That means that we're doing a good job during feature engineering because they appear to be in the top of the importances. And again, you can look at the top 10, bottom 10, and export the whole thing. Okay, let's close this. Here are the metrics. Now let's look over to the predictions. So here is the predictions section. And well, there are quite a few things you can do with your model. First of all, you can download the model right away. You can click this button here, and the archive with the model and with all the necessary code required to transform your test data set will be downloaded to your downloads folder, and you can then use it without internet access. You can predict with it locally, or you can implement it into your server, into your infrastructure. So it is yours forever. You can cancel the subscription to Neuton and use this model. The other two options are connected with model being deployed to the cloud, which is also a very neat feature. You can see here, this says disable. So I have just previously enabled it, but let's look at the fresh solution. So by clicking this button, the model, together with all the environment and the necessary code, will get automatically deployed to the Google Cloud and become available for you 24/7. And this is a very extensive part of any model deployment, and we have automated that completely. So once it is deployed to the cloud, and it takes about 2.5 minutes, you can start using it. You can use it with your web browser to make predictions like this, and you can use it via REST API to send requests to the model from your, say, mobile app or from anywhere with internet access. And it's very simple. This is just an example. This is the location of the model. This is the request example, and this is a response example. And we have here predefined samples in 4 languages, which you can just grab and implement into your setup. And a web prediction, say you have a data available right away and you want to make the predictions right away. You just click start. You grab that test data set, the new data without the target variable. Well, the only thing, it has to be in the same format as the trained data set. So all the columns have to have the same names and they have to be in the same places. And again, this is untransformed data. You just use it without any additional input. And you can just upload it like this. Click start. And so basically right now, the trained data set is being transformed and pre-processed, and all the features are being engineered in a way that was just performed on a trained set. but only this takes a smaller amount of time because all the knowledge has been acquired on the training stage, and now we are just applying that knowledge from dictionaries. And you can see in 15 seconds everything is ready. You can download your predictions in CSV format like this. And here we have this new feature, which is a part of our explainability office. Let's have a look. Let's view our predictions. So this is your test data, the original and transformed test data. And these are the predictions. And there is not only one column, and this is the predicted sale price, the predicted target variable. Here we also calculate a confidence interval, which is sort of a standard deviation, the possible deviation of the prediction, confidence probability. So this is sort of a self-criticizing, and the model tells us how confident it is in this particular prediction. And we also calculate the model to data relevance indicator for every row. And say you wanna understand, well, this house was priced according to the prediction at $144,000. What if this house had a different zoning, not RL but RH, for example? Or what if this had a different area? Or maybe what if it was built or refurbished not in 2003 or maybe in 2010? How would the model predict in this case? Well, you can quickly have a look. You can open any prediction with model interpreter. And here, well, let me quickly explain. So this is our predicted sale price. These are the features. These are the important features. And you can see how any change in any feature will impact your prediction. So for this particular example in your test data set, the garage cars was 2 in this house. So what if there were 4 cars, for a garage for 4 cars? Well, this would not impact that much, but it would raise the predicted value of the house by 1,000. Let's look at some other feature. Maybe if overall quality indicator was not 6, but 8, for example, well, this would raise the house value by additional $30,000. And once you make any changes, all the other relationships here will recalculate. So if the lot area was higher, and you can see how this would impact the price. And here on the right, there is a feature influence matrix. So while the slope is very, well, I believe it's called steep, while it goes up very, very dramatically, you have the influence here, which is very high. So with even minor changes in this value of this feature, you have a major changes in the predicted price. While on the contrast, while you are here at the saddle point, then the feature influence is very low, no matter how much you change the lot area. Once it is over, say, 74,000, whatever this is, this will not change the predicted price that much. And let's just for fun have a look at some categorical features. You can add features here because here are only the top 10. Let's find some categorical feature here. Well, I believe this one here, central air, is categorical. This should be added here. Well, just a moment. This additional adding additional features was just deployed to the platform very recently, and I'm here at the development environment. This may not work very properly right now, but the main takeaway here is here you'll have the categories, and you will instantly see how different your predicted value would be if the categories would be different, if you would have changed some categorical feature to a different category. So this is and this gives you an idea of why the model is predicting what it is predicting, and how the model behaves. So we've done an extensive job trying to create explainability to a neural network, which is by default not very explainable. This is usually considered as a black box. But this is one of the first tools which allows you to understand the rationale behind the model. And one more thing that I've promised but did not go through. Let me show you an example how the data is transformed. because this is quite an extensive process. Now I have a data set, this house prices data set after pre-processing and feature engineering, but it's not very interesting to look at this particular data set. Instead, I'll show you Titanic. And for those of you not familiar with the data set, Titanic is a hello world of machine learning where you learn to predict whether the passenger will have survived the crash or not. So this is a data set, and this is actual data from the ship, from the Titanic ship. And using this data set, you learn to predict whether one will have survived or not. And this is the target variable. And this is a raw data set from Kaggle. And despite the fact that this is a starter data set just for learning machine learning, this is not a very simple one. So this is pure text in here. This is a binary variable represented as text. There are missing values here in the age column. So this is a complete mess with letters and symbols and numbers in here and spaces. Lots of missing values in the cabin. This one here is a categorical variable with 3 different categories represented as text. So none of that works for machine learning. No algorithm can handle that. So what we're going to do, first of all, well, the passenger ID column will be dropped because this is just a consecutive number. It is irrelevant. This one will be also dropped because this is not considered as text. Textual column must have a few more differences between the rows than this variable represents. If this would have been some raw text, some messages from emails, this would be processed as a bag of words. This will be just binarized and represented as numeric integers. Missing values, it's a big subject. Most data scientists will impute them by mean or median or just some constant value or a most frequently used category in the data set. Those are all valid approaches, but we don't do none of that. Instead, we perform small end-to-end machine learning projects for each column with missing values. So we'll break this down into the rows with available data and missing values. We'll train models, machine learning models, and predict these missing values. And that way, all of them will be unique and much more accurate. And moreover, we'll save those models in an archive to be later deployed on your test data set pre-processing if similar columns will have missing values. So this one will be, for example, this is a categorical column. There are many ways you can transform it. Yeah, and you can do one-hot encoding, you can do factorization, you can do frequency encoding or mean target encoding. And you never know which one works better. Maybe this is ordinal and this has to be 1, 2, and 3. Or maybe this is not ordinal, like in this case, and it has to be one-hot encoded. And we'll do all of these iteratively, and we will benchmark it against a baseline model and see which one works better. And that way, for each particular data set, its best encoding will be found and used for encoding the categorical variables. We'll also find and treat outliers, and all the data will be normalized in a scale between 0 and 1. So this is how your data set will look like after data pre-processing. Now, and you can see in this case, this one has been one-hot encoded. So this is already machine learning feasible. And since we have selected feature engineering, at this stage, we'll calculate, we'll based on threefold cross-validation, we'll build another baseline model and record the metric. And once we will proceed to the feature engineering stage, we have 16 iterations of different feature engineering, and we'll create features by batches. So after creation of a new batch of new features, we'll then again validate and score based on our target metric and see whether this has improved our baseline model. If it has, these new features stay in the data set. We will renew the baseline model value, and then we'll again create additional features based on consecutive validation. So after feature engineering, Titanic is going to look like this. So these are your features after data pre-processing. And these are all the new features that were created automatically, and all of them have been validated, and they have proven to be of importance to the model. Now, this is approximately another 800% of data created in this data set. So, and all of them seem to be important. So that's it for data pre-processing. There is a lot more to it, which we just don't have all the time. Now let me close this, and if you guys have any questions, I'll be happy to address them. Please go ahead. Blair, you with us?
Yeah, so I think so far we have one question. It is, are the diagnostic charts using the full data set or just a training data set? I assume maybe they're referring to the EDA.
Well, yeah, if you are referring to the EDA, then the exploratory data analysis is performed on all of your trained data. Uh, and there is no other data available by default once you train the model, because frankly speaking, usually when you are getting ready to predict something, you only have the statistics, or maybe you're lucky enough to have some holdout data set, or you have used a portion of your training data as a holdout data set to test your model individually. But we use all the data available at the point of training the model.
So that was an anonymous question. So if whoever typed that, if you have a question.
There is another one, yeah. Hi, Ivan. Yeah, that's a great question. So it seems that you need to be a data scientist to use the software. Well, really not. If you would just reverse engineer what I've done on the platform, I've input the name of the solution. I have dragged and dropped the data. I have selected the target column, selected the metric, and start training. So that's all I had to do. I went into lots of detail for you guys just to explain what's going on under the hood. But being not a data scientist, you really don't need any of that information, because it's going to work as expected by just pressing 7 buttons throughout the process. The only thing you have to understand is the metric according to which you would like to measure the model accuracy. We will always provide you with a default metric for every type of problem. But if you have your special metric in mind, you can select it from the metrics list. So really not. This is you can use this being an analyst or just a salesman in a tire shop trying to predict the sales for the next season or something like that.
Yeah, okay. One of our customers was even CEO actually used our platform. But we have some other questions. Is it possible to use your platform for data sets in Russian texts?
Yeah, sure, no problem. We can use the Latin and Cyrillic. So it could be Russian or not Russian, really doesn't make any difference. All of that will be pre-processed, and the model will get trained. Okay, so one more question. Can you speak more about the missing value imputation model? What is the objective function being optimized, or the general form of the model? Well, we've tried many different models, and since this is not the most important model to be built, we have stopped our choice on the decision trees, because given the lots of experiments, we have understood that this is the cheapest and the most convenient solution. And we use the default optimization metric as a cross entropy. In this case, we don't optimize for because this is not the task of this project to optimize for some selected metric. We are just predicting the missing data. In this case, some default, say in this case, cross entropy would be just perfect. I hope I've answered your question. If not, please. There is something else. So who's the target user of this tool? Blair, you want to get that?
So I think there's 2 different audiences that we've seen adopt using our tool. One is, I'll state it more from a business perspective, organizations who may have a data analyst, may have what some people call a data citizen, and they were looking to begin to use machine learning. So our particular platform, let's say, was an enabler for them. And then also we've worked with organizations that have a more robust IT staff, where they may be looking to use our platform to increase their bandwidth and or downstream some tasks so that their data scientists can focus on other things. So we've seen that our platform is, valuable to both ends of the spectrum if you're referring to a user. Let's see if there are any other questions. While we're waiting to see if there's any other questions, I will share with you guys the different plans that we make available. I typically like to start from right to left. So what we call the third law, which is more or less like our enterprise plan, is if you look at all of our functions and features across all of our subscription options, we, for all intents and purposes, we don't scale our functions and features. So let's say the model interpreter or the what if tool, the feature importance matrix, feature engineering, data pre-processing, they all exist in all of our different plans. How we make a commercial distinction between our different plans is starting with the third law is an ability to download the models. So it's typically an annual plan. So we typically find that maybe some more of our more enterprise customers are looking to use the third law, because at that point they can actually physically download the model. There's no tiebacks to our platform and they can implement it in our ecosystem. Then we have the second law. Our second law, as I mentioned, same functions, same features. It's also an annual plan. Just the ability to do any downloads is the only distinction between the second law and third law. And then the first law is a monthly plan, basically the same thing as the second law, except that there's not an annual commitment. Our gravity plan, which is the plan that I mentioned in the beginning of our discussion, is our free plan. So it's a $0 subscription fee. And again, how we make the distinction in this particular case, of course, there are no downloads. We do put a monthly limit on the amount of API requests that you can do per month. So if you would like to, if you had a use case or a need where you know for certain that you won't go over 5,000 API requests per month, then you could use our gravity plan. And then the other limitation is the amount of web predictions you can do at a time. So if you are okay with running less than 100 predictions at a time via the web tool, then the gravity plan would make sense for you. We have a couple of different programs that we have going on. If you guys are interested, we'll certainly be in contact with you guys after the call. More than likely, you'll hear from one of my colleagues. His name is Jeff. But I'll take a look to see if there are any more questions. And I'm not sure if they are. So if you're interested in anything related to pricing, certainly Jeff will be able to speak with you guys in regards to some of our other plans and what different programs we may have going on there. And the different problems that we're solving at the moment, I think Danielle mentioned this in pretty good detail, is regression, classification, and then we're also doing time series, and we do some limited LLP on the platform. So we're not doing imaging or CNN at this time as it relates to our AutoML solution. So certainly if there are any other questions, we'll be certainly happy to answer them. If not, we certainly appreciate all of the time that you guys have spent with us today. Hopefully you were able to get some value out of today's discussion and demo. And with that said, we will wish all of you guys a good day, good afternoon, depending upon where you may be. So thank you guys. Have a great day. Thanks, Danielle.
Thanks, everybody. Bye-bye.
Bye-bye.